We present our WACV work on Exo2EgoDVC, dense video captioning of egocentric procedural activities using web instructional videos. Our goal of this work is to understand procedural activities captured from head-mounted egocentric cameras. Particularly, our work is motivated to describe the activities with natural language to enable textual interpretation of the task procedure. Unlike traditional action classification using discrete action labels, we formulate this task as dense video captioning, predicting time segments and corresponding captions jointly. Our contributions in this work include: first, creating a new dataset for egocentric dense video captioning; second, addressing the view dynamics in training datasets using hand-object tracking and view decomposition; and finally, demonstrating the effectiveness of knowledge transfer from existing web instructional videos to captured egocentric videos. Previous studies on egocentric action recognition have largely explored predicting categorical action labels. While they enable the interpretation of ongoing actions across real-life videos, their outputs of the task have limited expressiveness due to the simple combination of verb and noun prediction. Another line of work has addressed activity understanding with the formulation of video captioning, which is typically benchmarked on web instructional videos combined with text annotations. The task of video captioning is to output coherent step descriptions, specifically predicting the time segment and corresponding caption of each action step. For example, Ucook2 proposed a video captioning task on web cooking videos, while UMakeup focused on web-based makeup videos. However, egocentric video benchmarks are still limited because they are not abundant on the web. The existing MMAC captions dataset was created through dedicated recordings, resulting in a small dataset of approximately 16 hours. A question we address in this work is whether we can bridge the gap between abundant web videos and unique egocentric videos. We believe utilizing web videos is key to improving egocentric video captioning given the scarcity of egocentric video sources. To enable transfer learning from web instructional videos to egocentric videos, we are initiated to record egocentric videos with video caption annotations. We capture scripted activities using egocentric cameras by borrowing the captions from Ucook2. Particularly, we collected 43 hours of videos, corresponding to 11% of the Ucook2 videos. By aligning two caption definitions, our dataset, EgoYC2, contains consistent vocabulary list and caption granularity compared to Ucook2. Then this allows us to fine-tune models from Ucook2 to EgoYC2. Next, we propose to resolve dynamic view changes on source web videos and target egocentric videos. For egocentric videos, the camera viewpoints constantly shift due to the camera wearer's motion, which complicates the analysis of activities. To address this, we propose hand-object interaction mining to identify interaction areas from images using tracking algorithms of hands and objects. On the other hand, we find that web instructional videos often contain various views and scene cuts, which also poses a challenge to video understanding. To resolve this, we propose to identify ego-like shots including hand close-up views to help adapt across view gaps. Our proposed Exo2Ego view adaptation is performed by assuming an intermediate view domain, an ego-like view. Given web videos containing various views, we first decompose the views into exocentric views captured from a far third-person camera, and ego-like views indicating hand-object interactions. Then, we perform gradual domain adaptation, by adapting models from exo to ego-like and finally to egocentric view. In our implementation, we perform the source view decomposition with an off-the-shelf face detector. We label face-detected frames as exo views and the remaining frames as ego-like. Next, we run hand-object tracking to mitigate the impact of dynamic view changes in egocentric videos. Particularly, we propose to utilize temporally coherent hand detection and fine-grained detection of interacting objects. Then, tracked hand-object crops are encoded with a feature extractor denoted as phi. Finally, we design a view adaptation scheme through view invariant learning based on adversarial adaptation. The extracted features are mapped to be view invariant with the adversarial guidance from a view classifier. Additionally, a captioning network G generates predicted segments and captions. This view-invariant learning is performed to adapt from Exo to Ego-like views during pre-training and across the 3 views during fine-tuning. The qualitative study confirms the improvement of our proposed view adaptation over the baseline without view-invariant learning. We observe the improved time segmentation and higher captioning quality by reducing noise in the generated captions. We perform a quantitative study with common dense video captioning metrics, and the results show the effectiveness of our proposed method. Regarding egocentric video representation, our method, which uses cropped videos with hand object tracking, outperforms the baselines with raw video features and cropped video features. In addition, compared to standard source-to-target adaptation in MMD and DAN, our gradual adaptation with the intermediate ego-like views enhances captioning performance. In summary, this work proposes an Exo2Ego view knowledge transfer of dense video captioning with a newly created egocentric dataset, called WACV2025. We address the problem of view dynamics by using interaction mining on egocentric videos and view decomposition on web videos. Our future work includes pre-training from less constrained source data, without relying on caption-aligned UCOOC2, and studying the ability of recent large video language models on egocentric videos.